Okay, friends, so over here in Excel, I've brought in the Gallup data from '08 to 2015, along with the Gallup Healthways Wellbeing Index obesity percentages. I've changed the label to sample percentage. Instead of U.S. adult obesity without mentioning that it was drawn from a sample, I've put sample percentage up there because I want to draw that point that the numbers we're looking at here are not the entire U.S. population. They're based on sample data. And that needs to be addressed because otherwise people looking at it are going to say, well, that doesn't represent the entire country. Well, it does if you adjust it with a margin of error. And that's what I also did. I took a little dive and I went on a Google hunt and found the margins of error for all the ones I could find. I could not find 2008. So that one's a mystery. I don't know what the plus or minus is for 25.5%, but I managed to find the other ones, so that's good. What I'd like to do now is take a look at these numbers adjusted with their margins. Because, you know, we shouldn't say that 28% of America has or is obese. Just like we shouldn't say here that 27.7% of America was obese. Just like we shouldn't say here that 27.1% of America was obese. That's not true. As we've mentioned before, you have to measure everyone to do that. So what I'm going to do is I'm going to create what are called error bars on this chart. And this is going to show us the margin of error visually. So I'm going to click up here and the little dispensary tab, and I'm going to go down to error bars. Now, I didn't click on it yet. I just hovered over it. You see those little tiny wings? Oops, I guess I can't do that. Little tiny wings that show up. Those are pluses or minuses around a given value. But the problem is I don't know what those numbers are that Excel has chosen to plus or minus. So I'm going to go over to the little arrow and go more options. And then I'm going to move the graph a little bit so I can see. There we go. I'm going to resize the graph and move it so I can see the options and also see the graph and also see the column with the margin of error in it. Direction, I think we want both up and down. We don't just want minus and just want plus. We want to go plus or minus. End style is your choice. You can take the caps off or leave them on. The big thing is the error amount. We want them to be custom because any other one of these things is using the exact same number on all of those years. And we don't want that. We want it to be different for each year. So we went custom, specify value. It now asks you, what should the plus and the minus values be? Now, it has it, for whatever reason, Excel puts equals 1. So they're adding and subtracting 100% to these numbers right now, which obviously we don't want to use that. So I'm going to press backspace to erase that. And I want to use these values for the positive. And I also want to use these values for the negative. And when I press OK, and I'm going to close this now so we can see it better. What you're now seeing is you're seeing the plus and minus in visual form like we saw on the chalkboard in the last video. In the last video, we said in 2015, we're fairly statistically confident that between 27.8 and 28.2% of the population are obese. Well, now you see that. You can now see that. Well, here's the important thing. Gallup also called that a quote-unquote record high, implying it had never been this high before. Well, the problem with that is if you go back to 2014, 2014 had a margin of error of 1%. That means if you apply that 1% to 27.7, it might be as low as 26.7 or as high as 28.7. Which means it may have actually been higher in 2014 than it was in 2015. You see what we're getting at here? Because these ranges of numbers overlap each other, we cannot say with certainty that this obesity rate is higher than this one, because it might not be. It might actually be lower, higher, or the same. It might also be the same. And as a matter of fact, if you work your way backwards, you see that there are certain ranges that don't touch. For example, 2012 does not touch 2013. So statistically, statistically, assuming you trust the sampling method and assuming you trust the margin of error calculations, you could ostensibly claim that 2013's obesity rate is higher than it was in 2012, ostensibly. But the problem with that is if you go back even further, 2010s eradicates both of those because 2010 overlaps 2012 and 2013. This is getting a little bit harder to see. So what I'm going to do is I'm going to click over to this next tab. And what I did here was same exact data, but presented horizontally instead of vertically. I think this might be easier for us to see because we're used to seeing number lines on the horizontal. So these numbers down here are percentages, 25%, 26%. When you look here, there's so much overlapping of intervals. It's hard to know if there actually is an increase left to right. I mentioned kind of in passing before that it appears there's a trend left to right. Well, that's pretending that margins of error don't exist. Let's take a step back here. Why did Gallup call it a record high? And what's interesting is as I went back and found all of these margins moving backwards in time, or I guess backwards is this way, as I found all these margins moving backwards in time in my Google searches, almost every year said obesity inches up, inches up. Here, when it was in here, they said it's remaining steady. Well, why would you make those kinds of claims when the actuality of what's going on is so uncertain? I blame this guy right here. His name's Ted Turner, and he gave us CNN, probably 25, 30 years ago now. Somebody decided, maybe it was Ted, that we needed to have news 24 hours a day, 7 days a week, 365 days a year. CNN was the first 24-hour news network. I'm not sure why people think we need to have news changing 24 hours a day, but the problem with news changing 24 hours a day is that you begin looking at stuff like this and saying, that's a new record, when it might not actually be a new record. In the next video, we're going to look at some other data sets with margins of error and see what we can glean from them.